Hello everyone. In this video, I am going to explain you about to find out output sequence y of n for given two discrete time domain sequences like x of n and h of n. And in this video, we will see the steps you should follow to find out output sequence y of n. Here, in step 1, choose an initial value of n, that is the starting time for evaluating the output sequence y of n. If x of n starts at n equal to n1 and h of n starts at n equal to n2, then output sequence n is equal to n1 plus n2 is a good choice. Now I will explain this step 1 with one example. Now here is the example. And the sequence x of n will be like 1, 4, 3, 2, and h of n sequence will be 1, 3, 2, 1. If we observe, these two sequences are nothing but represented in discrete time domain. So here, by seeing this discrete time domain signal, here is one arrow mark mentioned for x of n sequence, nothing but the arrow mark mentioned amplitude is going to be the time instant at n equal to 0. And this arrow mark right side amplitudes are going to be the positive time sequences amplitudes. So these 3 amplitude at the time instant n equal to 1 and 2 amplitude at the time instant n equal to 2. And coming to the arrow mark left side amplitudes are going to represent the amplitudes at negative time instances. So, this 1 amplitude at the time instant n equal to -1. Now, if we see the h of n sequence, there is no arrow mark mentioned in this discrete time domain signal. Means the first amplitude representing at the time instant n equal to 0. So, the first 1 amplitude at time instant n equal to 0, and this next amplitude is going to be the time instant at n equal to 1. So 3 will be at n equal to 1 and 2 amplitude will be at n equal to 2. 1 amplitude will be at n equal to 3. So this is the method we should follow to find out the which amplitude is representing at which time instant. So in this step 1, we are going to find out the output sequence is going to start at which time instant. So here is given one principle, n equal to n1 plus n2. So here this n1, nothing but sequence x1 starts at n1 equal to -1. By seeing this signal, the signal is starting at n equal to -1. So here n1 will be -1. Now coming to this n2, the sequence h of n signal starts at n2 equal to 0. So this h of n signal is starting at n equal to 0. Now we will find out output sequence y of n is going to start by using this principle. So n will be equal to n1 plus n2 means -1 plus 0 will be equal to -1. So for these given two signals, the output sequence y of n will be going to start at the time instant -1. So, output y of n sequence is going to start at the time instant -1. Now, in step 2, we are expressing both sequences in terms of the index k variable. So, instead of representing both sequences x of n and h of n with independent variable n, instead of that, we are going to use k independent variable. So this is the signal regarding x of k and this is the signal regarding h of k with independent variable k. So here, coming to step 3, fold h of k about k equal to 0 to obtain h of minus k. So by doing time reversal operation on this h of k signal, we are going to find h of minus k signal will be like this. Now continuing with step 3, after finding h of minus k signal from h of k signal, we need to find out h of n minus k. Here n will be the time shift it is representing, and here to obtain this h of n minus k, we are considering the signal h of minus k, and by depending on this time shift n, here if this n is positive means we are shifting the signal h of minus k towards right side. If this n is negative, we are shifting h of minus k signal towards left side. Now coming to this example, the output sequence y of n is going to start at the time instant n equal to -1. When we are doing convolution of given two discrete time domain signals x of n and h of n, the principle we are going to use is that y of n will be equal to summation k equal to minus infinite to plus infinite x of k h of n minus k. Now here we need to find out firstly the amplitude at the time instant -1. So we are substituting n equal to -1 here. Y of -1 will be equal to summation k equal to minus infinity to plus infinity x of k h of -1 minus k. Here this x of k amplitudes are here we are represented, and this h of -1 minus k can be obtained by considering this h of minus k signal shifting towards left side by the time instant one time. So here this is the signal representing h of -1 minus k. So if we observe these two signals, h of minus k signal time instances are from 0 to -3, and h of -1 minus k signal amplitudes are at the time instant from -1 to -4. So this signal is shifted towards the left side based on this time shift. Now coming to step 4, here multiply the two sequences x of k and h of n minus k element by element and sum the products to get output signal y of n. So firstly we are going to find the amplitude at the time instant n equal to -1 means we are finding y of -1. So for that one we need x of k signal, and that will be this one, and h of -1 minus k signal, and that will be here. Now by considering the time instance regarding x of k and h of -1 minus k, here the x of k signal time instances are from -1 to 2, and h of -1 minus k signal time instances are from -4 to -1. Now here, so the common time limits for both the signals by considering most negative number -4 to most positive number 2 here, by considering x of k and h of -1 minus k. So here the summation limits are going to be from -4 to 2. By considering amplitudes regarding x of k and h of -1 minus k amplitudes, the amplitudes will be like this, and by doing multiplication, after that finding addition of these products, the y of -1 will be equal to 1 here. Now coming to step 5, increment the index n, shift the sequence h of n minus k to right by one sample and do the step 4. Now here we are going to shift the h of -1 minus k signal towards right side to find out further amplitudes like y of 0, y of 1, y of 2 and so on. So here we shifted this signal towards right side like h of 1 minus k from the signal h of minus k. So before going to this one, we need to find out the amplitude y of 0 by considering x of k signal this one, and h of 0 minus k means nothing but only h of minus k. Now by considering amplitudes regarding h of minus k signal and x of k signal, so these are the amplitudes we can write. After doing multiplication and addition operation, the y of 0 amplitude is going to be 7 here. Now moving further, this signal towards right side to find out y of 1, We are considering the signals x of k and h of 1 minus k. So this will be the x of k and this will be h of 1 minus k. And here also the summation limits we are considering the most negative number minus 2 here and most positive number 2 here. Now by considering the amplitudes regarding these two signals, by doing multiplication and doing addition operation, we can find out the y of an amplitude is going to be 17 here. Now coming to step 6, repeat step 5 until the sum of products becomes 0 for the remaining values of n. Now moving to find out here output amplitude at the time instant 2, that will be y of 2 by considering x of k signal will be from this and h of 2 minus k signal will be from this. Here the time instances are from minus 1 to 2 for h of 2 minus k signal, and here the time instances are from minus 1 to 2 from x of k signal. So by considering those summation limits, by multiplying amplitudes and doing addition of these products, we can find out the amplitude y of 2 as 20 here. Now further moving the time shift n, we may find out the amplitude at the time instant 3, that will be y of 3 by considering x of k signal will be this one, h of 3 minus k signal will be this one. Now by considering amplitudes of regarding these two signals, multiplying those amplitudes with respect to their time instances and adding those products, we can find out the amplitude is 16 at the time instant 3. Now we can find out y of 4 by considering the signals x of k from this and h of 4 minus k from this signal. Now multiplying respective amplitudes at their time instances, we can find out the amplitude as 7 at the time instant 4. So that will be y of 4. Now similarly we can find out y of 5 amplitude as 2 here. Now if we further move the h of n minus k signal again one time towards the right side, there is no common amplitudes at the time instance, so that the output amplitude is going to be 0 after the time shift 5. So h of 6 minus k is also, if we found the y of n signal amplitudes are going to be 0 towards plus infinity. Now finally, the output sequence y of n for considered example, here the y of n amplitudes are 1, 7, 17, 16, 7, 2. Now here, this is the arrow mark representing the amplitude at the time instant n equal to 0, and arrow mark left side amplitudes are going to be negative amplitudes. Arrow mark right side amplitudes are going to be positive time instant amplitudes. Now by following these steps regarding discrete time domain signal convolution, we can find out the output sequence y of n. Thank you for watching this video.